should, in spite of all the people that didn't show up today, give us an extension on that project. And then they'll all be like, oh, it's due Wednesday, so they'll come to it, Wednesday.
Oh, man.
And then you come in, you're like, oh.
That would be awesome, but I'm not going to do it too bad.
They'll freak out the night before and start it the night before for no reason. It'll be great.
You gotta reward good behavior, like showing up in class, and then.
I got to give you a standard father response. I'm not going to reward you for what you should do.
But discipline them for.
Like when I started mowing the lawn, what do I get? You get dinner. I got dinner before. Well, now you earned it. I'm like, oh shit. All right, great. Thanks, Dad.
Smoke up, Johnny.
What section?
What's that? 11.2, 11.3, extra credit. It's a good thing looking out for each other. Yes?
She has a question.
Doesn't seem to be true.
What is the project supposed to look like?
All right. That's a good question. So, some of you guys, when you turned in your outline, I put little notes on there. Maybe some of it was related to your number system, which is we talked about later. But maybe some of it was related to the civilization. Some of you guys didn't give me enough about the civilization you chose. Whatever it is, if it was all okay, you can just turn that back in with your project. Right? You don't have to rewrite it. It's not an English class. You don't have to give it to me with MLA and all that kind of business. The commas in the right places. Well, that would be nice, but your number system stuff, you have to give me some kind of backstory if you created a backstory. You've got to give me quite a few examples of conversions. So I'd say at least 5 conversions each from Hindu-Arabic to your system and from your system to Hindu-Arabic, showing all the work. Do you guys follow so far?
What if I had the 2 number systems?
Then give a few for each.
But the other number system, the mathematicians one, that's just going to be our number system with different symbols. So it's really necessary I show the conversions because it's just like.
Give me an example. I mean, give me an example. If it's a really simple one like that, you don't have to do a ton of them. You just say, well, this would look like this. And you're going to list out the symbols you're going to use, right? Okay, cool. So obviously list out your symbols. If there's something interesting about how your symbols are constructed, you got to give me some idea of what that looks like and give me examples that show me that. Are you guys with this? Yes.
So, you written or typed? Both?
Totally. I'm cool with either.
Okay.
If your handwriting is as bad as mine, then maybe, type it up.
So do that, type that, and then have the conversions written.
Yes, beautiful. I love it. So you can leave yourself some space, however you want to do that, as long as it can follow what you're trying to show me and tell me, I'm good.
So you include the system and research before you with the number system project?
Yes, cool. I like it. And if I said that you didn't have enough in there or something, then you should beef it up a little bit before you turn it back in. Cool. And of course, it's due this Wednesday.
If you weren't here today, like Monday for those of us who came.
Let's say it one more time.
I said it's due this Wednesday if you weren't here today, but for those of us who valiantly came to class,
Valiant.
Yes.
Way, where do you come from? What is in the way? Are there dragons? Do there be dragons on the
Yes.
route?
I'll give you the rest of my sandwich if
I wanna-
you extend the due date.
Say again?
I'll give you the rest of my sandwich if you extend
Oh my
the due
God.
date.
What kind of a person would I be if I turned that down? I'd
It's
be...
chicken, ham, salami, cucumber, pickles, mustard, mayo.
bacon.
No.
No pepperoncini? No bacon?
No, they're Swiss and provolone.
No pepperoncini? Banana peppers? Whatever you call them on this coast.
Hey, they inflate the prices up here. I can't be getting everything, or else.
Well, screw that. It's not worth it.
Just bring the sandwich.
All right. You want to bribe me, you want to find out ahead of time what kind of sandwich I like.
Okay.
So that was a poor attempt. What's that?
Eh?
Wow. That's amazing. But be careful, don't walk near his house. There be dragons. All right. So let's get back into... we made it a little bit into section 12.1. And we finished up the geometry section. We did that one section out of chapter 11. So now we're going to continue into chapter 12. If you missed last time, we had an interesting discussion involving goats and doors and things like that. Yes, good. All right, so if you weren't here, you're looking at me the right way about goats and doors and such. Spider goats, that's right. My mutant spider goats.
There's a spider in my soul.
There's a birdhouse in your soul. All right. You guys, what is that? All right, so I want to kind of build you up to what it's going to look like on a quiz or a test from chapter 12. I've got a little handout I'm going to give you later. It's kind of, I teach statistics too, so part of stats is probability. It's a huge part of stats, actually. So let me come at it this way here. So last time we talked a little bit about, just barely talked about some really basic stuff about probability. So for example, roughly 11% of Americans are left-handed. I don't know why I capitalized it. Right? Obviously I'm not. Maybe I am. Maybe that's why. No, I'm no. That would explain why I write so horribly bad. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 valiant young people that came today. There's only 20. Yes, I am. You put yourself out there. How many people in here would you expect to be left-handed, do you think?
11%.
11% of 20. And 11% of 20 is 2. I like it, because 10% of 20 is about 2.
I'm
I
about
like it.
2.5%.
How many of you guys are left-handed? Anybody? Oh, that's awesome. You're left-handed? Or you ambidextrous? I was like, oh. Dude, either hand. Just showing off. All right.
3% of Americans don't have left hands.
I know. That's the whole other thing. There's a comedian talks about somebody getting pulled over for having a phone. He's like, what if I didn't have my hand? What would you do then? This is my bonus hand. I'm just talking with my bonus hand. I'm stealing from this guy, but oh well. I forget his name. But that's interesting. I didn't expect it to be exactly 2, but that's one use of probability is to have a good guess for how many of something's going to happen. So if I'm going to, so like for example, anybody ever been on a plane before? Yes, all right. What happens sometimes, people, I don't know if it's ever happened to you, unfortunate people waiting in there in the waiting area and they have an announcement and then people get called up and they've been bumped. Why does that happen? Why do they bump people? Because they're mean. They're like, it happened to me and I took my own planes. I'm going to make it happen to you. Nah, well, why do people get bumped off of planes? Does anybody know what that means and know why? Too many people. So why the hell would there be too many people? They know how many seats they have, right?
Isn't it when people buy different types of tickets?
No, the airlines do it on purpose.
They're dead.
Yes. No. Yes, but no.
It's like advertising. They want other people to want the business.
Well, that would suck. See, that would be bad PR. It's bad PR to have people get bumped, right?
Because of the weight, maybe that people have checked in too many bags or checked like whatever bag they checked.
Oh, no.
They did that actually.
They do that sometimes?
Yeah.
I would be surprised if that were true, but people taking more and more and more. It's not that. Because for the number of seats on a plane, they've got it overestimated for how many baggage they can take. Most airlines should be able to handle that. Yes?
They expect people not to show up.
There's a probability that people will not show up. So what do the airlines want? This plane's gonna fly.
They want a full bird, dude.
They want a full bird, right? Why?
To get maximum.
So that maximum efficiency, maximum economy, right? They're gonna get the most money out of that situation. They're gonna go anyway. They want as many people in their seats as they can.
How do they choose who gets bumped?
Well, they ask, have you ever heard, like, we'll give you $200 in vouchers. We'll give you $300 in vouchers. We won't give you shit. We're just going to bump you off now when I call your name. I don't know. I've been given the option before. I've never been bumped, though, but I don't fly a lot.
What was the option for you?
It was like $100 for that airline. For Southwest is my airline, right?
Do they also they give you that and hook you up with like another flight to where you're going?
They should. Normally they don't. Well, they do. They get you where you're going, but I mean, not free or something. But they don't charge you transfer or something, right? But they give you a little credit. I don't know. It's up to the airline what they want to do. That's all beside the point. Let's come back to why they do this. In order to have a full plane, if there's a probability that people don't show, they have to overbook. So part of some of the people on their roles that they've employed are in charge of analyzing the statistics on this. And they're trying to figure out if they bump too many people, that's bad PR, right? Those people are going to go out there, they're going to write on the blogs, going to go to whatever, and they're going to complain. If they get too much of that, that's bad for them. But at the same time, if they go too low and they don't have enough people come, they're going to be losing money. Right? They're not going to have enough people in their flights. I like it. Cool. So the study of probability, that's one immediate use that we're all aware of that happens. Right? We're going to get bumped because of the fact that they want their planes as full as possible, so they have to bump people because they're going to sometimes, people are going to show at a higher rate than they thought. You guys are kind of with me. One misunderstanding of probability is, what are the chances if I flip a coin that I get a tail? 50%. Why?
Because there's only two sides.
There's only two sides. So what we just did, if I flip a coin, the probability that I get tails is 1 out of 2 because there's two sides. So did we actually flip a coin?
No.
No. Right? Does somebody have a coin? Do I have a coin? I have a coin. No way.
I don't care when you use the pocket change.
Oh, look at that big roller. Anybody else have a coin want to play along?
It's gotta be heads.
Yeah.
It is? Okay.
That's your dollars, heads.
Cool. All right. So play along with me. Be careful. Oh, I see somebody already going. So do this for me. Let's just flip it 5 times safely. As safe as you can. Keep track of what you get. As I drop my... I can't lose that, man. That's big for me.
Damn, you guys are bad.
I don't know where that went.
All right.
But aren't they still paying for the plane tickets? When you don't show up?
That was
All right. Yes. Oh, that's what you got? That's weird. I like it. It's not impossible. It's not too freaky.
It was heads, tails, heads, tails.
So you got heads, tails, heads, tails. Okay. So you didn't get what I got. All right.
I got.
All right. Now listen. Did anybody not get something? Like you only got 5 tails or 5 heads. I don't like the way you look. I don't agree with that. You look like you're. Did you do it?
Not agree with. You can't do that.
I think he's not being honest. Is what I'm saying.
Valid.
You're being valid. Everybody got some combination of tails and heads? Would it be impossible for somebody to get 5 heads, 5 tails?
No.
All right. So on a single coin toss, does it mean anything that the probability of getting a head or tail either way is 50%?
No.
No, it doesn't mean a damn thing. So what does probability mean? Did I already tell you about my little brother and his whole thing about?
Yes.
Yes, so he believes everything's 50-50 because either it's going to happen or it ain't, right? So don't be a doctor, Jim. Don't be a meteorologist. Don't be a lot of things. Just don't do those things, please, Jim. Please.
Is it gonna rain today?
There's a decent chance today, yeah. And for San Diego, it's pretty good. So what does it mean then to say that the probability, when I flip a coin, the probability is going to be tails is 50%? What does that mean? What does that mean?
Half the time it'll be tails.
All right, beautiful. Half the time it'll be tails. So it only means something when I have done this a lot. Right? So this is a theoretical probability. Because it's based on just what could happen. We didn't actually do anything at that point. We knew there was 2 sides. We knew one of the sides was a tails. So there's a 1 out of 2 chance you're going to get tails. These would represent what's called empirical probability. So this first one, the probability of tails, the one I did would be 2 out of 5, 40%. And this other one would be 2 out of 5, 40%. I like it. So is it strange that that's not the same as this? For 2 reasons it's not strange.
Well, it's not an even number.
I love it. If somebody did get 50%, that's freaky as hell. Did it land on its side, but just a little bit towards one or the other side? That's weird. I don't know what that would mean, right? So what then does it really mean for the probability of it to be tails to be 50%? What does that really mean? What does it mean? Does it mean something when I do it once?
No.
Doesn't mean a damn thing when I do it once. It doesn't really mean much when I do it 5 times. Really, it doesn't. Because it wouldn't freak me out if I got 5 heads. When would it start to freak you out? What if I flipped a coin 50 times and I got 50 heads?
You really need a life.
That's not that.
That's that. You took my joke. Every time I say that, I'm like, number one, something's wrong with your life.
If you did it 100 times and you got 100 heads, then it would be really.
Then it would be exceptionally freaky. What do you start to
If
think?
At the same velocity and at the same distance from your hand and caught it.
No, reference Jurassic Park, Jeff Goldblum, scene in the car. Thank you. Chaos
The
theory.
water?
Chaos theory. Yeah, the thing on his elbow when he's trying to flirt and he's talking about chaos theory. Chaos theory. Chaos theory is where you start something at the same exact conditions, but you get different results. Because as humans, we can't control all the variables in any given situation. So that's chaos theory. It's just too many variables. Anyway, that's going a little bit further than I want. Let's come back. Yeah, let's knock it back down. So if I do it 100 times, if I flip a coin 100 times, how many heads and tails would I expect? 50, exactly. So, yeah, I agree. Somewhere around 50 times, 100 times. Number one, I'm worried about my life. Number two, if I get nothing but heads, what are you going to start to think is true?
Fucking cheater.
There's something wrong with the coin.
The coin. Somebody tampered with the coin. Maybe they weighted it so it comes out to one side or the other.
Both sides are heads.
Both sides are heads. I just never stopped to look. Heads again. Who would have thought? I like that. Wait a minute. That's awesome. All right. So empirical probability. You're gonna love this. It doesn't sound like something that I made up, but empirical probability approaches theoretical probability as you do something a lot. So it's called the law of large numbers. And the limit, as you do something, as you run an experiment a lot of times, oh, there they all are. So these two, this is empirical probability. This is basically, the word empirical references observations. And this is theoretical probability, because I didn't do any observations, I just based it on what could happen. These approach each other, or these approach this, through the law of large numbers. If I do something a lot. Cool. So if I flipped a coin 1,000 times, and at this point it just decided this is my life. If I flip a coin 1,000 times, I should get 50% roughly tails. I should be getting closer. Is it impossible to get nothing but 1,000 tails with a perfectly fine coin?
No.
Because the other thing people don't understand is, if I asked you to write, don't even flip a coin, just write 10 flips in a row. Try it out. Write 10 random flips. What would the result be? Try to write that out. Pretend like you flipped a coin, but then write the results out without actually doing it. Or pretend like you flipped your sandwich. Pick a side to be heads, pick a side to be tails. The thing that people don't understand is it's almost impossible to not have a string of 3 or 2 or 5 or something. When people write out random, they sort of start to do this, and then they go, well, maybe there could be 2 heads, and then they go back to this, and maybe there could be 2 tails. So, yeah. And this would be so easy to pick out as not truly random. Because the coin doesn't have memory. So if I flipped a tail, the next thing being a tail is still 50%. So it wouldn't be amazing if I flipped the tail on the second one, and the next one is still 50%. So it's very possible that I can get like 5 tails in a row. There's a tail right there. Flipped on the reverse. I like that. You didn't have to actually go that far with it. Okay, so there's the whole idea of law of large numbers connecting these 2 types of probability. So something you might see, a classic probability problem would be something like, in some bag I've got 4 red chips, 5 green chips, and 8 blue chips. Right? And I want to know the probability that if I pick one chip out, what's the probability that it's green?
You gotta add the total.
I like it. So what's the total? How many things could happen?
17.
17. So 13 and 4. So 17 chips could happen. That's a weird way to say it, but I don't care. 17 chips could happen.
And then you want green, and there's 5.
and I want green,
There's 5 of the green.
I got 5 chances to get it. So probability basically is always the number of things matching what you want. Not things matching, there's matching what you want divided by the total number of possibilities. Probability formulas almost never change from that. They're always this. Now we're going to learn some things, and you're going to question my sanity if you haven't already, but it's always this, believe it or not. Now the thing we can't do yet, but I want to give you a little bit of a preview of where we're headed. This was easy because I picked 1 chip. Now let me ask you, if I said I picked 2 chips, we're not going to quite get here today, but I just want to give you an idea of what we have to work through to get to this. There's something you actually have to ask me that I have to tell you before you can calculate anything.
What chips do you want?
Well, no, so from the same bag. Okay, well, yeah, okay. So even before you can answer any question I ask you, you all know what kind of questions I could ask you. So before you can answer any of them, so let's say the question is, what is the probability you get a red and then a green?
Did you already take out 1 green from the first one?
Nope, separate problem. So we reset it. I like it. But that kind of leads you to something you need to ask me as I pick these 2 chips out.
Are you keeping them out or putting back in?
Exactly. So if I pick 1 chip and I feed it to my little brother, that'll be one situation. But if I put it back in, why does that matter?
Because it changes the ratio.
Changes the numbers, and which would change the probabilities. I love it. Kick ass. So I'd have to tell you if this was with replacement or without replacement. So then, we don't currently know what "and" means. What do we do when we see "and"? No.
Subtract.
I like it. We're going to go through all 4 that we know. No.
Multiply.
One of those things, possibly, but not quite.
Multiply.
It's going to be based on one of those operations,
Divide.
depending on what I put here. Not divide. So why isn't this easy? Like, tell me this. What could happen? Give me an idea. What's all the things that could possibly happen?
You could pick 2 blues.
I love it. So that's a good start. So this would be called the sample space for picking out 2 chips at a time, right? So I can get 2 blues. Blue, blue. What else could happen?
Blue, green.
That's crazy. Blue, green.
Blue, red.
Blue, red. What else could happen?
Green.
Green, green.
Green, blue.
Green, blue.
Green, red.
Green, red.
Red, red. Red, green. Red, blue.
Red, green, red, blue.
More than likely, you're gonna pick a variation that is blue something else.
Why is that?
Because there's more blue.
Yeah, exactly. It makes sense. There's more blue, so probably the most likely thing up there. What's probably the most likely thing up here is blue, blue. No matter how I pick it, with or without replacement, because there's the most options for that. It only makes sense. Cool. So how many things are in this sample space?
17.
No, so here's one thing, right? Blue, blue is one thing.
9.
There's 9 things, right? 1, 2, 3, 4, 5, 6, 79. And why does that make sense? Because, so the sample space size is 9. Why does it make sense there's 9? How many options are there for the first chip?
3.
3. How many options for the second chip?
3.
3. So for every one of these, there's 3 of those. So 3 times 3, there's overall 9. Cool. I like it.
But that's not right.
What's up?
Because it's the order as well.
So how many options are there? So I'm going to pick 2 chips, right?
Mm-hmm.
2 chips. So how many chip colors are there for the first chip I pick?
There's 3.
3 options, 3 choices. I love it. So I can have any of those 3 choices. One way you can represent that is red, blue, green. That's a little tree, right? Now if I do pick red first, how many choices do I have next?
3.
3. So for every one of these, there's 3 of these. Right? Again, red, blue, green, so forth. For every one of these. So that's 3 options for 3 options. That's 3 times 3. That's why it makes sense you got 9 options total. So you can always multiply how many options you have on each stage of something and get the total number at the end. Kick ass.
I use this math every day at my job. I have to take these like quizzes, and rather than like reading everything, there's always 3 questions, so I'll pick one, and then I'll go through each one, and if it's not right, then I'll just keep doing it. So,
Oh, okay, so you use something like this.
yeah, the idea.
Okay,
So,
I like it. Cool.
I do that.
An example in real life is crazy. Let's see. So the thing is, if I said, let's do something related to this a little bit, and then we'll come back to this. So here's my sample space. If I was talking about a couple having 2 kids, so say a couple. Now in reality, if you know any biology, the probability of getting a boy versus probably getting a girl, most people think it's 50-50. We're going to assume it's 50-50, but it's actually slightly tilted towards men, because nature seems to like to kill men off. We like to die early. So it's kind of neat how there's a sort of a balance to that. There's a slight favoritism towards having male babies, because somehow it works out. It knows that they're going to die off sooner than women, on average. You guys kind of with me so far? So if you're born a male, we got the short end of that stick, but it all depends on what you do with your life, right? If you're going to have 2 kids, what are all the possibilities?
Or girl.
You can have 2 girls.
A bother. When you're both genders.
Yeah, we're not talking about that.
Yeah, they haven't made that choice yet. We're talking about right at birth. Oh, I see what you mean. It's not a choice. I got you.
A bother.
That's why when I say right and left-handed, that's why I was waiting for somebody to say they were ambidextrous, right? So let's
Are we going to include that, or?
let's keep it simple, right? Let's say it's a girl or it's a boy for right now.
Yeah.
This is not getting any political. This is just keeping the math nice. Later we can talk about how to make the math incorporate more options. Well, let's keep it boy and girl. Is that cool? Are you guys okay with that? Are you very socially motivated? I like that part. That's cool. I'm good. I'm with that. But let's keep the math simple for right now. I like it. So you can get girl, boy,
Boy, girl.
boy, girl,
Boy, boy.
boy, boy. I like it. Now the difference here is there are 4 things, of course. 2 times 2 is 4. Makes sense. Are each of these things equally likely?
No.
Well, in reality, not quite, but they're close enough. We'll say the probability of girl and the probability of boy, we'll say they're both 50%. Close enough, right? So are these all equally likely?
Yeah.
Yes. Why were these not equally likely?
Because there's more chips.
There's more blue chips than red or green, for example, right? So, of course, this is going to be most likely. So the probability of any of these is going to require us to know a little bit more math. The probability of one of these, making some assumptions, I understand, but still, what's the probability to get 2 girls? How many are girls? How many are 2 girls?
The wisdom of your brother.
So 4.
1 out of 4. 1 out of 4.
1 out of 4. There's 1 situation that's 2 girls out of 4 situations. So it's a 1 out of 4 situation. It's a 1 out of 4 chance.
That's a whole other.
So guys, hey, so there's 4 things that could happen, and one of them matches what I'm looking for. So the basic idea of probability never changes. It's always the number that matches what you're looking for divided by the total that could happen. There's 1 that matches what I'm looking for out of 4 situations. So it's a 1/4 chance. I like it. Cool. Kick ass. So this one it's not going to be the same thing. So if I say what's probably blue, you can't say 1 out of 9. We already know that can't be true because that should be the highest probability. It can't be the same as everybody else. So these are equally likely. When you have equally likely events, the probabilities are easy. When you have events that are not equally likely, then the probability we have to figure out how the hell to do that. So we're going to work towards that. Right? And I just want to talk about one situation before I give you this little handout to try out. Let me see what you guys think about this here. Say I talk, let's say I ask people a question. Let's say that these people are less than 25 years old. These people are at least 25. Let's say these people say yes, these people say no, these people say maybe. I don't know. So you can make up your own question. Okay. So I like to get this kind of problem, and I do it based off of data very often about you guys. So let's make up some stuff. Let's say 4 of these people say yes, and 11 of these say yes. Let's say 15 of these say no, and 3 of these say no. 2 and 7. Okay.
Hey, Jeff.
Hey, how you doing, Jeff?
Pretty good.
Oh, jeez.
So if I ask you questions like, I pick one person, what's the probability that that person is somebody who said no? What do you have to do first before you can answer that question?
All of it up.
I like it. So how many people said yes?
15.
15. How many said no?
18. 9.
9. How many are less than 25?
Yeah.
And then how many are at least 25? 21 is great. All right, 42. I like it. So the one little thing to be careful about is people sometimes add these 42 and these 42 and then make 84. Yeah, that's crazy. You just double counted everybody, right? But it's a nice little check. This should be the same as that sum. So what is the probability that I pick somebody who said no?
Out of just the answers that people gave you?
Yeah, in